Going to learn how to use the quadratic formula. It's day 2 of section 4. We learned 2 methods yesterday for solving quadratic equations. This is another method you could use to solve quadratic equations. You can use the formula for every quadratic equation there is. Sometimes though it's quicker to use factoring and the square root method, but this method will work for everything. So the key thing to do is to put it in standard form first. Okay, so what's important here is before we can even begin to use the quadratic formula, we need to put it in standard form first. Okay, so it must be in standard form. Again, remember standard form is the ax squared plus bx plus c, and it needs to equal 0, just like we did when we factored it. So the a that we're going to use in our formula is going to be in front of x squared. The b will be in front of x, and then the number or the constant is your c. So we're going to take each one of these values and we're going to replace them into the formula. And the formula is negative b, or opposite of b, plus or minus, and then under the radical sign, b squared minus 4 times a times c, all divided by 2 times a. So this formula is kind of handy. You'll probably see it on the SAT or the PSAT. So if you get any questions that mention the quadratic formula, this is what it is. So we're going to try and use it now. So I've written the formula over here to the side, but again, remember step 1 is to put it in standard form. It's the same thing we had to do when we factored it. So we're going to move the 2 to the left side. So we're going to add it. And now the equation we're going to work with is x squared minus 4x plus 2, and it's set equal to 0. Because again, remember, when we are solving these quadratic equations, when we solve for x, the x that we are getting here is the x-intercept. All right, so now that it's in standard form, I'm going to pull out my a value, my b value, and my c value. So on this one, my a value is going to be the number in front of x squared, so it's 1. My b value is the number in front of x. So I'll pull out negative 4. And if it's a subtraction sign, you're pulling out as a negative number. And then my c value is the constant. It's down here on the end, and it's positive 2. Now that I found what a, b, and c equal, I'm going to replace into my formula each one of the 3 letters. So the first thing I'm going to replace is this opposite of b, or negative b. Notice my b value is negative 4. So if you think of the negative b as saying the opposite of b, what I'm going to put in here is positive 4. You can also think of it as you're putting it in as a negative, and that's how it becomes positive. So then I'll replace the plus minus sign, the radical sign, and now I'm going to again put in b, which is negative 4. I square it, and then I'm going to subtract 4 times a times c. And the whole thing has a denominator of 2 times a, and in this case my a is 1. So now I need to simplify the denominator, and I also need to simplify what's under the radical sign. So I'm going to go ahead and I'm going to rewrite the 4, the plus minus. I'm going to do negative 4 squared, which gives me 16. And then I'm going to multiply the negative. I treat the negative, the subtracted 4, as a negative 4. And then that way, whatever number you get is the sign that's going to be there. So I multiply mine as a -4 times 1 times 2, which gives me -8. And then 2 times 1. And then now I'll subtract what's under the radical. And I get 16 minus 8 is 8. So 4 plus or minus the square root of 8 divided by 2. If the radical can be broken down, you need to simplify it. I can simplify the radical 8 or the square root of 8 into 4 times 2, 4 being the perfect square, and it's going to come out as 2 radical 2. So now my equation is 4 plus or minus 2 square root 2 over 2. If you can simplify all 3 of the numbers that are outside of the square root, you do that. This becomes a 1, this becomes a 1, this becomes a 2. Final answer here is going to be 2 plus or minus the square root of 2. I don't need to leave a denominator of 1. And the 1 in front of the square root sign is assumed. So final answer. Now, keep in mind, if they said to find them separately, you can also break this apart and you could say it's 2 plus square root 2 and 2 minus the square root of 2. That's what this plus minus sign represents. You write 1 with a plus sign and then 1 with a minus sign. Yes?
What I had done was, like, when it says the square, where you start the square root of 8, I had taken out 2 times 2 and put it to the 4, so it would be 8 plus minus square root of 2.
Okay, so you can't put it to the 4. It stays behind that plus minus sign.
Oh.
It's only going to stay out front of the radical. So it's got to stay right next to the radical. Example 2 is not in standard form. We need to fix it first. So I'm going to move the x and the -4 to the other side. So I'm going to subtract it. 2x squared minus x equals -4. Then I move the -4. And now I have 2x squared minus x plus 4 equals 0. If you were to have started and used the problem as it was, you're going to get the wrong values for your a, b, and c. They're going to have the wrong signs. So it must be put in standard form first. Now that it's in standard form, my a value is 2, my b value is -1, and my c value is 4. So now that I found a, b, and c, I'm going to plug it into the formula. And the formula again is opposite of b or -b. So opposite of -1 is +1. And then -1 squared minus 4 times a times c, all divided by 2 times a. So now I'm going to start simplifying what's under my radical sign. I'm going to first square the -1, and I get +1. And now again, I'm going to multiply these 3 things. And again, I use it as a -4. If you keep it as a +4, then you need to leave the subtraction sign there. And then if it's a negative, after you multiply, it's a negative, and it becomes positive. So I find it easier if when I multiply the AB or the 4AC, as I take that 4 as a -4. So -4 times 2 times 4 gives me -32. So that's why I put a -32 here. In the denominator, 2 times 2 is 4. I now need to subtract what's underneath that radical sign, and I'm going to get 1 plus negative 31 over 4. In lesson 1.3, we learned how to deal with negative square roots. I can't break the 31 down, but I can break out the letter I. I could break it into negative 1 times 31. So if it's a negative root, I need to pull out the letter I. So that's the only thing I can simplify on the 31 is the square root of negative 1. So final answer there is 1 plus or minus I square root 31 over 4. Again, if you want to break it apart, you could show it as 1 plus I square root 31 over 4 and 1 minus I square root 31 over 4. It is both of these answers. I'm okay with you leaving it with the plus minus sign. You will see that on the SAT, the plus minus sign. Again, check to see if it's in standard form, and it is. So I don't need to do any rearranging here. So now I'm just going to figure out what A, B, and C are. So again, my A is 1. My B is negative 3. And my C is negative 2. Now that I've found A, B, and C, I can now plug it into the formula. So again, I think of it as opposite of B. So 3 plus or minus B squared minus 4 times A times C. All divided by, or in the denominator of the fraction, 2 times A, which is 1. I need to simplify. So let me rewrite my 3 plus minus. And then I get 9 minus negative 4 times 1 times negative 2, and I get 8. Divided by 2. I need to simplify 9 plus 8. So now I get 3 plus or minus the square root of 17 over 2. Okay, number 4, some ugly fractions. Now, you can work with the fractions in the quadratic formula, but trust me, it's not going to be pretty. Okay, and chances are your answer is probably not going to come out very good. I would not make them decimals because the first one is a repeating decimal. So what I highly recommend you do is get rid of the fractions by multiplying all 3 pieces of it by the common denominator. Now, before I begin finding my common denominator, I'm going to go ahead and get it into standard form. So I'm going to subtract the 3 first and get it in standard form. So I get 2/3 x squared plus 1/4 x minus 3 equals 0. What is going to be my common denominator between 3 and 4? 12. I am going to multiply the entire equation and get a common denominator of 12. Once I have the common denominator, then I don't write it anymore. So when I multiply or try to change my 2/3 x squared Notice that it'll simplify with the 3 to a 4, so this becomes 8x squared. Then for my b term, 12 times 1/4 is going to be 3x, and then 12 times -3 gives me -36. Now I have a lot more manageable numbers for A, B, and C to work with. So my A value is 8. My B value is 3. And my C value is -36. I'm now going to put it into the formula. So now I'm going to plug in opposite of B plus or minus B squared minus 4 times A times C. All divided by 2 times A. We're going to get a really big number here. Okay, so I need to multiply -4 times 8 times -36, and I got 1,152. I multiplied the 2 and the 8 in the denominator and got 16. And now I've added 9 plus 1,152, and I got 1,161. Now, we need to break down that radical, or at least try. I'm going to reach back to probably elementary when I learned divisibility rules. And I learned that if I take my numbers and I add them, so for example, 1 plus 1 plus 6 plus 1, this gives me 9 as a sum. And I know my divisibility rule for 9 is if I take the numbers and I add them, if 9 will go into that sum, then I know I can divide 1161 by 9. So because 9's a perfect square, that's why I chose that divisibility rule. So I know I can divide 1,161 by 9, and I get 9 times 129. Now 129 can't be broken down, so that's going to stay under the radical. So then this, when I break it down, is 3 and then square root 129. Breaking the 161 down, or the 1161, I'm going to put it in here. So -3 plus or minus 3 square root 129 over 16. I can't simplify the 3's and the 16, so I'm finished. And there's my answer. Now, if you leave it as the 1161 and don't break it down, you're losing points on the quiz. Okay, so that's why it's going to be important you show your work so you don't lose all of the points. If you've shown work like this step by step, chances are you're going to get some type of partial credit. And then our last example has decimals. And again, I'm going to clear the decimals. You can use the decimals in the quadratic formula, but I just like to clear it. So in example 5, notice I have 1/10 x squared minus 1/10 x equals 3/10. So first thing I'm going to do is put it in standard form. So I'm going to move the 3/10 over by subtracting it. And then I get 1/10 x squared minus 1/10 x minus 3/10 equals 0. So in order to clear my decimal, I'm going to multiply everything by 10. So by multiplying my entire equation by 10, all I'm really doing is moving each one of the decimal points one time to the right. So now my equation's nice and super simple. It's just x squared minus x minus 3 equals 0. And now I have a nice manageable equation. My A is 1, my B is -1, and my C is -3. And now I'm going to replace A, B, and C into the formula. So opposite of B plus or minus b squared minus 4 times a and c, all divided by 2 times a. Simplify what's under the radical sign. 1 plus minus 1 minus negative 4 times 1 times negative 3 gives me positive 12. All divided by 2. I'm now going to simplify what's under my radical, and I get 1 plus or minus the square root of 13 divided by 2. And again, if you want to leave it like that, that's good, or break it apart. 13 over 2, 1 minus square root of 13 over 2. Either answer is acceptable. Yes?
Is there any that teachers prefer?
Okay, and then your homework is page 124, and you're doing 45 through 57 odd. So we only have one more method to learn. We will learn that on Monday, which is completing the square. And then we have a quiz on this and on the complex numbers on Wednesday. So your quiz is going to be on 1-3 and 1-4, and you're going to have to demonstrate all 4 methods. So you can go ahead and start on your homework, and then if you have questions, you can ask me. Again, remember the solutions are in all of the entire book is in that one file. No longer do you need to look for separate solution files. So look for the one, it's in the textbook module.